Hello everyone, so welcome back to our YouTube channel, and today's question is product of array except self. So we are given an integer array nums and we have to return an array answer such that answer of I is equal to product of all the elements except nums of I, and it is mentioned that the product of any prefix or suffix is to be fit in 32-bit integer, and we have to write an algorithm that runs in big of n time and without using any division operation. So let's just move to our examples. So it is 1 2 3 4, and the product will be x for 1 it will be 2 into 3 into 4, so it will 24. For 2 it is 1 into 3 into 4, 12. Similarly for 3 and 4. Okay, and in case of 0, I think it will all be 0 and except for that. So yeah, it is pretty much clear. Let's just move to the intuition part. We have our nums array and the output will look like, just write it for first time. It will be look like 24. Then for 2 it is 12. For 3 it is 4 to the 8, and for 4 it is 3 into 2 into 1, it is 6. Okay. For the basic approach for brute force 1, if one must think of an approach, it will be like we can use two for loops and like pass this array for both, and we will skip in another for loop if I equals to j. So it will be like for int I 0 to n. Okay, and similarly another for loop inside it for j 0 to j less than n, j plus plus, and we just have to skip for if I equals to j. We don't have to do the product in case the same position. So if I equals to j, we just continue. Else what we'll do, we create one variable here, product equals to product star multiply by nums of j. Okay, and after that we will just update our result array, and after this one, this for loop to result of I equals to product. Okay, so yeah, this will give our answer, but the problem is the time complexity here is big of n square, since we are using two for loops. Space complexity is big of 1 only, we are just using variable. So the interviewer will ask you to optimize this approach as it is taking a lot of time, big of n square. So the second approach that will come to the mind is to optimize this time. So what we can do, we can create one variable, let's just say int product. Okay, and for it is 1. After that what we'll do, we will product all the numbers into a variable, and we will divide each of them when we are building a result. So let's just have a nums array in the left for us to not go through again and again. It will be 1 2 3 and 4. Okay, now what is to be done, we will like go to all variables nums and update our product equals to product star I. Okay, now we get the product of all the numbers. It will be at the end 1 2 3 4, it will be 4 3s are 12 to the 24, so it will be 24. Okay, now what we'll do, when we are building a result for int I 0, I less than n, I plus plus, and result I will be equals to product divided by nums of I. Okay, so for first, if we are building a result, what it will look like, 24 divided by 1 will be 24, 24 divided by 2 it will be 12, 24 divided by 3 it will be 8, 24 divided by 4 will be 6. So we will get a result. But this approach will fail when the case of 0 comes. So if we can check, like let's just say our nums is 1503. Okay, and if we use the above approach, the product will be 0. Okay, and if we build a result, it will be 0 by 1 will be 0, 0 by 5 will be 0, but 0 by 0 cannot be determined, so it will fail here. Okay, and your code will fail. So for this, what we can optimize it, we can have a count of zeros, we can maintain a count of zeros. So we'll just take another variable, count 0. Okay, and we'll just check the count of 0 along with building our product. So the approach will be same that we have written above for int I 0 to n I plus plus, and we'll check if nums of I equal to 0, then we will update our 0 variable. Okay, else what we'll do, we will update our product, because in case of 0, how to get we the product of these 1, 5 and 3? So we will maintain a product of non-zero. You can call it as product of non-zeros elements. Okay, and it will be 5, 15 in this case. So product is equals to product star nums of I. Okay, so we have our count, we have our, so now we have our product and we have our count of zeros. So we have to build our result. So it will be int I 0, I less than n, I plus plus. Okay, now what we have to check? First, we have to check if nums of I is not equal to 0. So what it is? The case where the element is not, let's just have an example on the left so we will better understand. Nums equals to 1, 5, 0 and 3. Okay, so we are at this place first, and we'll check, if we'll check that nums of I is not equal to 0, so 1 is not equal to 0. So what it will do now, it will check the count of zeros that we have maintained in this variable. So if count of zeros is greater than 0, that means there is at least one 0 in this array. So we just have to update our resultant of I to the 0. Okay, if the count is not greater than 0, that means that there are no zeros in this array. So what it will do, it will update the rest of I to the product divided by nums of I. Okay, because in this product of non-zero elements, we have maintained the product of all. Okay, so it will resolve this case of 5 or 3. Okay, yeah, so this part is done for nums of I if not equals to 0. Now it will check, so there are two cases only, if it is 0 or not. So we have checked this, so it will come to else condition. Okay, and it will, what it will do, now it will do if count of zeros is greater than 1. What that means, so in this case, if it comes to here, now it will check the, so 1 we have got, if the number of zeros is greater than 1, then the product at here also will be 0. Okay, so if we check, take this example, let's just say 1, 0, 5, 0, 3. Okay, so for 1 it will be 0, for 0 what it will check, now the count is 2. So if it comes here and it will check if the count is greater than 1, so 1 is here only, 1 it will here, so the product will also be 0, because in this case the product was 15. Okay, and this condition will fail at that point. So it will update, if count is greater than 1, then it will update the rest of I to 0. If the count is less than 1, less than equal to 1, so it will update the rest of I to product. Okay, whatever the variable in which we have stored. Okay, so yeah, this is the solution for this approach, and the time complexity in this approach will be sorry, yeah, so time complexity in this approach will be big of n, because we are just iterating over the array one time. But what will happen, the space complexity is also 1. Now what is the case in this, because we are using this division operator here. Okay, this is the case that is most important. We are using this division variable here, and it is clearly mentioned, as we have seen in this question, that we don't have to use this division operation. Okay, so we have to like interviewer will ask you to optimize this, or like do another approach. So what will be the next approach? So what we can do, if we check approach number 3, we cannot optimize, we cannot like basically affect this time complexity. We can like use space complexity now. Now the approach will, if anyhow, like let's just have our nums again. Nums array is 1, 2, 3 and 4, and output is 24, and it is 12, and it is 8 and 6. Okay, so if we can see this question, if somehow we can maintain the product of for the ith position, for this position, if somehow we can maintain the product on the left and product on the right, then and we build our result. If we multiply this to this, 1 multiplied by 12, so we will get our answer 12. So like we can go with this approach, we can maintain a left array, or we can call it prefix, and right array, which is somewhere called postfix. Okay, so also we can write our nums. Okay, so what will it will contain, basically for ith position it will contain the product of all the numbers on the left. Okay, so when it comes to this one, it will check, since there are no elements on the left of 1, it will just have 1 here. Okay, when it comes to 2, it will product all the numbers on the left, so it will do 1. So how it is calculated, so this position, this left of I minus 1 will be product will with the nums of I minus 1, so we'll get our answer 1. For when it comes to 3, it will calculate all the numbers product on the left, so it will be left of I minus 1 with the nums of I minus 1, so 2 into 1 will be 2. Similarly here it will be 3 multiply by 2, it will be 6. So 1126, we get our answer. Okay, same for the right array, it will be for this, there is no right of it, so it will be 1. Okay, for 3 it will be 4 multiplied by 1, 4. Similarly for when it comes to 2, 3 multiplied by 4, it will be 12, and for 1 it will be 2 multiplied by 12, 24. Now if we build our result will be simple. Okay, left of I multiplied by right of I, so it will be 24 into 1, 24, 12, 4 to the 8, 6. So we get our answer, and the approach is very simple. So the pseudocode will be, let's just have a small pseudocode. So we just build our result left first. So if you can like start from the first index, it will be better. And for left of I, okay, so it will be, as we have mentioned, left of I minus 1 multiplied by nums of I minus 1. Okay, so it is the product of all the numbers on the left, so it will maintain. Okay, now for similarly for the right, we will go from I n minus 2, because for n minus 1 we will update initially, like it will be 1 1, as we have checked, this is 1 and this is 1. Okay, so it will go to I greater than equal to 0, I minus minus, and right of I will be updated to right of I plus 1, so it will update. Next, multiply by nums of I plus 1, so it will the product of both of them. Now we just build a result. Int I 0 to I less than n, I plus plus, and result of I is equals to left of I star right of I. Okay, and we get our result. So now what is the issue here? The time complexity here is big of n, which is very good for us, but the space complexity is big of n because we are using two extra arrays for it, prefix and postfix, and that will be the issue. So it will ask to you to improvise on that, the space complexity, to improve on it. So the next approach will be like similar to this one. So in that approach, what we can do, if we can somehow like place this, because we are first building this left, if we can somehow use this in our result only, and then when we are building a right, this right postfix, if we can just update the result array directly while product of this, so it will get our answer. So what we can do, let's just go with the approach fourth, and you without extra space. Okay, so what we can do in this approach, we will maintain one left variable and our result array. Okay, and while going through the nums array, we will just write our nums here, 1 2 3 4 for our memory. So while going through this, we will just update the result of I directly. So the approach will be for int I equals to, so we know for the zeroth element we just have to update, so we'll just result of 0 equals to 1. Okay, now we have our left equals to 1 because we have to maintain the product and update our result directly. So from 1, I less than n, I plus plus, and now what is the case? So we have to update our left to what? Left equals to left of this multiply by nums of I. Okay, nums of I minus 1, because we will start from here. Okay, not from here. We are updating this in the result array. We are updating 1 directly, so now we will start from here. So for this, what is it? This multiply by this. So we are using left, so left multiply by nums of I minus 1, all the product on the left, so we'll get our left. Now we'll just update the left of the result of I. Okay, now if it comes to here, now left will contain this nums of I minus 1 will be 2, and our left was 1, so 2 into 1 2, so it will update to 2. For in case of 3, for in case of 2 it will be 1 only. For in case of 4 it will be 3 multiplied by what was left, 2, 3 2 is 6, so 1126 we will get our answer for this first. Now the case comes, because we don't have to use extra space, so we will, how will update our right? So we will similarly use one variable right and assign it to 1, because 1 multiplied by anything is 1 only. And from the last, what we'll do, we will basically use a for loop from int I equals to n minus 1, I greater than equals to 0, I minus minus. And how we will maintain now, let's just check. If I is less than n minus 1, so we are not handling that case in the outside. So what we'll do, we have to like basically 6, 3 to the 6, we just need to 6. So if this I is not the last position, less than last position, sorry, so if I is not this last position, so we are just using doing the work from uh, n minus 1 elements. If I is less than n minus 1, it will update our right to right star. What will be nums of I plus 1. Okay, so we will get our right. uh, I will do a try run again so for better understanding, and our result will be result of I star right. Okay, because in the last approach we are what we are doing, left I star right I. If we are this result of I is here only, this is result of I, so what we'll do, we have our right, we have our result, we will product and store it in the rest of I only. Okay, and after doing this we will get our answer in the result array. So let's just do a try run here, small try run. Okay, we'll erase it and we will have our nums 1, 2, 3 and 4. Okay, so for this, for maintaining the left, we have a result. Okay, initially left is 1 and result of 0 is 1, so this is 1, it will come to first. Okay, so and left will be updated to left was 1 star nums of I minus 1, nums of I minus is this, so left will be now 1. I will write it with another pen, better understanding. So left now is 1. Now what it is, updating result of I, result of I was this 2, corresponding to 2 it will be 1 because we are assigning left to it. Similarly when it comes to 3, left will be left star nums of I minus 1, left was 1, and now left will update to 1 star to 2, so 2 will come to here. Similarly when it comes to here, it will be 3 star left, left 2 3 is 6 here. Now we get our result in this form 1126. Now when it came to the case of right, okay, uh, so right is 1 and result is this only. So from the last we are using this. So if this is the place for 6 is here, we are not doing anything for 6 because when we are building a result from these product, it is here we have built, so we don't need to do the case for it, we need to do for rest of the elements. So 6 will be here only. When it comes to 2, so right will be right star nums of I plus 1, so right is 1, nums of I plus 1 is 4, so 4 1, so right will be 4. Now rest of I, this 2 will be equals to 2 star 4, 2 star 4 is 8. Okay, so we get our result now 8 6, we build our result half of it. Now when it comes to 1, it what it will do, right star what nums of I plus 1, nums of I plus 1 is 3. Okay, 4 star 3, now right is 12. Okay, and 12 will be multiplied with this one, so it will be 12 here. Okay, now right will be updated to I will come here, right will multiply with this 2, so 12 star 2 is 24. Now this 24 will be multiplied with this one, so we get our result 24 12 8 6. Finally we got a result. So in this, the time complexity is big of n since we are just iterating over the array, and the space complexity is also big of 1 only, as we are just using two variables right and left. Yeah, so I think we are pretty much clear on this approach. Now we will move to our coding part. Okay, and we'll better understand from like while writing the code. So let's just write the code first. So we will get our size, let's just say nums dot size in the n variable. Now we'll directly write the code for the optimized solution. We have our left in the 1. Okay, and we have our resultant in a of size n. Okay, now rest of the resultant of 0 is equals to 1, as we don't have to do anything for the first index. For int I 1 till I n, less than n I plus plus. Okay, what we have to do now, we will update our left to left star nums of I minus 1. We will update our result of I to left. Okay, so first part is done. So this is the first part. We will first part. Okay, now for the second part, in which we have to like build the right and result directly. So what we'll do, we will start from the n minus 1th position, or we can start directly from the n minus 2th position, and we will check if I is greater than equals to 0 and I plus plus, sorry, I minus minus. Now what we'll do, we will update our right to right star nums of I plus 1. So it will be multiplied with 4. Okay, 2 multiplied with 4. Now result of I will be multiplied with result of I star right. Okay, now the result is finally built. Now we have to return our arrays. Okay, think we are pretty much clear on this approach. Let's just try run over the first example. Yeah, it is working fine for the all the example test cases. Okay, we have to wait for a few minutes. It is running. Yeah, I think it is working fine for all the test cases. Let's just do a submit. Yeah, it is working for all the test cases. Yeah, thanks everyone for watching. In case you do like this video, please do subscribe our channel, and for the all the approaches except for the optimized one, please write the code in the comment section. I will review and also share the GitHub repository link where I've mentioned all the codes. Thanks everyone for watching.